Hello. Can anybody hear
Hello.
me?
I can hear you.
Sounds great. So I'll share my screen. So hello everyone. I'm Darshan from the Client Foundation team, and uh, hope everyone's doing well. And I'm also a Node.js core collaborator. So the thing is that when I joined Postman, I got to share a little bit about myself in a small description. So I said that, hey, I'm a Node.js core collaborator. And when that was posted in the launch channel of Postman, I found that some of you were really interested in that. Some of you DM'd me in Slack and asked me, hey, how can I be a Node.js core collaborator as well? And I thought, hey, instead of sharing this knowledge with only a few of you, why not make a whole presentation out of it and share it with the whole of Postman so that everyone can benefit from it? So I welcome you all to this presentation on contributing to Node.js. So let's get started. This is my GitHub profile, and as you can see, I've joined the Node.js organization on December 9th last year, and this shows that I'm really addicted to green squares on GitHub. In case you're not very familiar with these, every day you make a meaningful contribution to open source, you get green squares on your profile for that day. And this is about me being a Node.js core collaborator. So in case you didn't know about that, a core collaborator is a person of a Node.js, of a GitHub organization who has write access to the repository. So yes, I have write access to the Node.js repository. I can merge changes, which everyone can submit. So yeah, that's about me. And I'll start off with by clarifying a few questions you might have about this presentation. So why should Postman contribute to Node.js? Well, when I started working on Node.js, I found that there are people from all these big companies like Google, IBM, and Red Hat. They're all contributing to Node.js, which is a great thing. But unfortunately, I didn't see much people from Postman doing the same. So since we are a leading company in the networking category, and even Node.js is such a leading software in the networking category, so we can go really well hand in hand. So we can take part in this competition and show all these big companies who we are, what kind of engineers we pocket inside Postman. So that's one thing. And the other thing is about influence in open source. So we can be on the bleeding edge of networking innovation. So there is this pull request that implements the quick protocol in Node.js. I'll open it and show it to you. So this is the one. As you can see, this is a pretty big thing. Like James Null is implementing the quick protocol again. In case you didn't know, this was there in Node.js and it was removed for various reasons. And he's adding it back in. So as you can see, it's a pretty big change, 25,000 lines added and 71 files changed. And the great thing about this is that it's still open and you can suggest your changes over here. And you can shape the PR as you want, provided your changes make sense. And as you can see, it's a really active thread. Like people are streaming in every now and then and adding their stuff over here. So it's a great thing you can contribute to. And the next thing, it's about JavaScript. So we use lots of JavaScript inside Postman. And Node.js is literally the thing that exposes JavaScript to the server-side environments. So we can technically learn how Node.js uses JavaScript under the hood so that we can learn how to write really efficient JavaScript. So there are a few really odd things going on in JavaScript, which if we keep following Node.js, we'll get to use all of these things inside Postman to keep our code really efficient. So for example, this one, let's look at this function here. So it's called read, so it definitely has something to do with reading. And as you can see, it takes in this variable called n. And the odd thing is that it's not used anywhere else in this function. So you must be wondering why it's there in the first place. So similarly, a person named Ayase, he thought that, hey, this seems unnecessary. So let's just remove it from the function definition. And he opened a pull request to do the same. And it didn't work out because, even I thought that this is pretty valid, and I gave my +1 on this. But then I thought, this is inside the HTTP module, and it's a really efficient module, and people really take care of the way the pull requests are made before merging them. So I couldn't really think of a case where such a thing would pass into HTTP core. And I thought of pinging the Node.js HTTP team, and boom, there's Matthew Kalina, this guy, and he's a prolific HTTP contributor, and he came up with the reason for this thing. So as it seems, it's a bug inside V8. I won't call it a bug, rather a performance thing. So the thing is that if you don't have this additional variable filled in, you would have some performance issue. And so Ayase, he was kind enough to change his pull request to add in the very reasoning for this thing over here. And finally, the pull request got merged. And if you read this, he has added a note saying that argument adapt frame issue might be solved in V8 engine V8.9. And in case you didn't know, the most recent Node.js version, this one, it's version 17. And if you look at the process.versions over here, you'll see that we use V8 9.2 right now. So in case anyone's interested, since V8 is upgraded right now, you can publish a pull request removing n and this comment saying that, hey, V8 is upgraded right now and we can make this change. And I hope someone makes that change. Other than that, the other reason that I could think of is that we use lots of Node.js here. So why not return the favor and help everyone else also? The very point of open source, basically. And moving to the next slide. So say you've been working on the Postman app repo for a long time. And then suddenly I come up to you and say that, hey, you've been doing great work. Could you please do some work on the Starship repo? It's probably something you've never heard of, but it's a really great project in progress. So it's a great thing. So, and that's one thing. And the other thing is that today I'm asking you to contribute to Node.js. So it's a new project to all of you. So you must be wondering, how is this whole experience different, contributing to a project that's new to you and it's internal to Postman and something like Node.js? Well, the differences here are that when you're working on an internal project of Postman, everyone is very amiable over here, and you can jump into video calls straight away when you face a problem. So you end up solving problems together as a team. But unfortunately, that's not the case inside Node.js. You get to work alone most of the time. So you skim through the issues thread and you find some issues that you find to be really interesting. And you start looking at the code, finding the places of the code that's relevant to the issue you're trying to solve. And then you hack on your changes locally, and then you send your patch to Node.js. And there are two kinds of things that can happen after this. So either your changes are in the right track, and some of us maintainers might come and suggest a few little nitpicks so that you can polish your pull request before merging it. And then we'll finally approve your changes and get it merged, which is the good thing. And in case you've put in all your work and your pull request is not on the right track, you'll see a bunch of -1s over there. And so eventually you'll have to close your pull request. And that's just sad. And there's nothing you can do about this, except you can train yourself. So if you keep working in this sort of an environment, you're basically working alone, and you're learning how all these huge maintainers think. Like they're maintaining a big project like Node.js, and you see their train of thought. And by making changes that align with their thoughts, you'll train yourself, and you'll end up with better decision-making capabilities. So that's a good point here. And another thing is that when you're making pull requests to Postman internally, your code gets reviewed by a small set of people. That's not the case in Node.js. Technically, it's all of public media that's looking at your pull request because it's open source. And so it's easier to get all these little bugs detected in your code really fast. And the last point that I could think of here is that in Postman, since you're familiar with most people you're working with, it's rather easy to convince them with the kinds of opinions you have. And that's not the case in Node.js. So all these maintainers you have in Node.js, you have never really seen in your life, and they don't know you. So you need to try really hard to push your changes so that it convinces them. So you need to have really good points to say that, hey, this is the right way to move forward and we should be doing this. So yeah, you get better at convincing people. And next slide. So how do we contribute to Node.js? So this is pretty standard, like most of other open source organizations on GitHub. So we have issues. So you can create really detailed bug reports so that everyone who's looking at your issues can know what really is going on. They can reproduce this locally in their own environments and hack on their changes. And you can also reply in their threads. So you see an issue where the person has not formatted the code correctly or hasn't said which platform this thing fails on. So you can kindly ask them to add in all of those details, and they would do it. And you could also start working on that issue yourself and submit your pull request. And speaking of pull requests, we really encourage pull requests here in Node.js. But one thing we don't really like is when people start asking for permissions. So I've seen all these issues where there are so many people saying that, hey, may I please work on this change? Is this available? I would really like to help out. Please try not to do that. This is open source, and anyone can work on any issue and make their pull request. And sometimes you have multiple pull requests open for the same issue. And I would say that it's completely fine. This is software engineering. there are multiple ways of solving the same task. And sometimes both the tasks look completely fine. And the way we merge them sometimes depends on which of the contributors are really active. So if we say that, hey, you can do these changes and it's a different way of solving the problem, and the person says that, okay, and he or she adapts to what we said, we would happily merge those changes. So yeah, go ahead with pull requests without asking for permissions. And then reviews. This is something that's sort of underrated. So when you start off with contributing to Node.js, you might feel sort of confused because you've never sent pull requests to Node.js before. And so you must be thinking, hey, how do I do this? I don't feel really confident. So one thing you can try is go to the pull requests tab of Node.js and look at the pull requests that you find to be interesting, judging by the title. And you go to the code section and you start reading the code. Sometimes the changes are really small, something that a beginner might find comprehensible. And you keep reading the code, and if you find any part of it that you don't really understand, that's not relevant, that's not implied from the description of the pull request, you can kindly ask the author of the changes to explain what he or she has been doing over there. What is the intention of the change? And that is a great thing. It helps to clear out the reasons for every little change in the implementation. You get to learn how you're supposed to make the changes. And the next person who comes in as a reviewer, he or she might find your comments to be really helpful, because he gets to know what's really going on in the mind of the contributor when he or she has made the change. And the other thing over here is the help repo. I'm not sure if you guys are aware of this, so I'll just show this to you. So this is a repository in the Node.js organization. And as you can see, it doesn't have much code over here. So most of the activity here lies in the issues section. So all kinds of people come here and ask questions related to Node.js. And sometimes us maintainers, we reply to them, we try to answer them. And when these are answered, we close them, or even the questioner, he or she might close their issues. And the great thing here is that we are not restricted to have only maintainers to respond to all of this. You guys can respond to this. Sometimes you'll find really good questions like inject C or C++ add-ons to WASM. So this is not really a kind of question you would come across every day. So you might try tackling this question on your own. So here's one of the maintainers. Even he's not very aware of WASM and the whole internals of this. So you can go into the code and learn how it works underneath and try to tackle this. And by doing this, you help this person, any other person who comes in searching for this issue, and also you help yourself. You get to learn more about Node.js. So those are the ways in which you can help in Node.js by contributing. So next slide. I'll discuss about the architecture of Node.js, how Node.js works under the hood. So as this diagram shows, Node.js is this thing over here, and it has lots of sub dependencies over here, all these projects. I won't call them small projects. Some of them are even larger than Node.js itself. So V8, OpenSSL, zlib, CRS, and libuv. So how does Node.js tie all of these together? So, V8, I guess most of you are aware of this already because it's a very popular JavaScript thing. So V8 is the JavaScript engine inside Chromium. And even this is an open source project. It's a Chromium project. So Node.js takes a hold of all the code inside the V8 repo and puts it inside this folder called deps and uses it from there. And how does it use it? Well, V8 exposes a C++ interface with which you can communicate with JavaScript. So Node.js uses these libraries like OpenSSL for the crypto stuff, zlib for compressions, CRS for DNS, and libuv for the event loop and the operating systems related stuff. And since these are all written in C and C++, it takes a hold of the useful functions that you might want to expose to the JavaScript side, and it creates all these C++ interfaces that calls all of these functions for you and attaches them to the JavaScript code via V8. So over here of all these libraries, libuv plays a really big part. So as I said already, it does the event loop part. So every next tick, you're basically querying the queues, the best queue system you have in your operating system. So libuv is a really interesting C library, which does the if-defs in C for you. So according to each platform, it would select the best queuing interface and all other operating system related stuff and expose that to you so that you can use them from JavaScript. So that's about the Node.js architecture. And now I'll move to the demo. So I'll show you the Node.js repo for a while, the way the code is structured. So as you can see, Node.js is mostly written in JavaScript and C++. And to show you how all of this is structured, I'll show the code in the terminal. So this is a local clone of Node.js, and this is the list of files and directories you have inside. So all the C++ code lives inside src, and all the JavaScript code lives inside lib. So I'll explain how this JavaScript and C++ communication thing works by walking you through one of the most basic functions inside one of the most basic modules inside Node.js, which is the fs module. So when you do require fs, this is the file that gets required. So just like any other JavaScript module, you have the module.exports object filled with all the functions that you might find useful in the fs module. So we have close, chmod, and all these things. And today, specifically, I'll look into the stat function. So this one. So in case you didn't know, this is the official documentation of fs.stat. So from the name itself, it's implied that it gives you some statistical information about a file. So you pass in a path to a file or a URL or a buffer or anything like that. And then there is an optional options object, and then there is a callback. So it would call the callback with an error if there is one, or the second argument would be the stats object that contains all juicy statistical information of the file that you're interested in. So let's look at the code. So this is fs.stat, all of this. A really small thing you might think. So this is how it works. So when you do fs.stat, as I said, the options object is optional. So there are basically two legal invocations of this function. So you do either fs.stat, then you pass in path, options, and callback, or you do fs.stat path and a callback. So since the second argument would be a callback in the second case, so options would basically not point to the options object, it would point to the callback object. So we do the check over here. So if options is a function, we move that to callback and we assign an empty object to options. And after that, we have some validation code over here. So this one would pass the callback object through a function and it would validate it. And in case of any error, it would throw the error to the caller. And then there is path, which does a similar thing for the path. If there is an error, it would forward it. And then we create this request object. And then we do the final call over here in this function, which is to a function called binding.stat. So stat seems okay. It does the statistics stuff, obviously. But what's binding over here? Let's search for it in this file. So binding gets defined over here. It's the return value of this function called internal binding when it's invoked with the string called fs. So what exactly is internal binding? If I search for internal binding over here, you might see that this is the very first definition of it. As you can see, it doesn't get defined. It just gets used over here, like a global. For example, we have require. Require doesn't get defined over here. It's a completely Node.js specific thing. It gets defined inside Node.js, and you just use it from user line. So similarly, internal binding too is such a thing. So you might think, hey, then let's just check it out over here in the REPL. Internal binding, and then fs. Okay, we have an uncaught reference error. This is because internal binding, this thing is not exposed to user land. It's only there inside the internals of Node.js. So only when you're inside the lib folder can you use internal binding. You can't use it anywhere else outside, unless of course it's exposed in some way, which is not a good thing. In case you find that it's being exposed from somewhere, please file a bug or try to send a pull request fixing it. So, as I said, this is a global from the internals of Node.js. So, what is the bindings object? Well, I can't really show you the bindings object right now, but I can show you something that's very similar, and that's exposed to user land, which is process.binding. When you do process.binding and then fs, and you assign it to, say, another variable, you get this big object, and it contains these handles to all the C++ functions that really call libuv and all these other dependencies of Node.js to do all the actual computation. And you shouldn't be using this in your applications because these are raw C++ functions. As you saw in the JavaScript side, we do the validation from the JavaScript side, and you're not doing that from the C++ side. Yeah, you'll find some validation code, but that's generally like the assert call in C. So when you do assert, it crashes your process. So when there is an error, you generally don't want to crash your process. You might want to handle that as an exception. So I can show you a way in which you can crash Node.js right now. So if I call fs.stat with nothing, as you saw, it expects us to pass in the path, the options, and a callback. And if I pass nothing, okay, that's not the one, fs.stat, this one. So if I pass nothing, there is a crash. And as you can see, it's an assertion failure. And it comes from this file called src/nodefile.cc. So as I said already, source contains all the C++ files, and this is a C++ file. We follow this convention of calling them with the .cc suffix. So yeah, it it comes from this file. So I guess most of you haven't seen such a log before. So let's look at this together. So it's coming from this function called node:/fs stat, which takes in this argument, and it has a void return type, and it has this number beside it, 1032. So this is the line number over here. So let's take a look at that file at line number 1032. So this one. So when I go to line number 1032 over here, there is a macro check GE. This is a macro that basically hides an assert call, and it checks whether argc is greater than or equal to 2. So what is all this stuff? Let me explain this to you. So when we're calling stat, this is the function that gets called. So as I already said, we tie up all these things with V8. So how do we do that? Well, if you go to the bottom of the file, you'll see node module context-aware internal and node module external reference. So these again are two utility macros, and you pass in fs, that's the name of the module, and then you pass in this function called initialize, and then another called register external references. So these functions, they have a very tied interface. You can't write anything other than these. Sometimes you might not even have to use all these arguments that are passed in, but it's necessary because we follow this interface. And what you see here underneath is V8 code. So environment over here refers to one instance of Node.js, the whole Node.js runtime. So it's getting a hold of the env object, and over here it's setting these methods. So on this target object. So that's basically the object that gets exposed to JavaScript. So for example, for rmdir, this string, it referred to the rmdir function from inside C++. So if I search for stat, this is the function. So when you say stat, it would call stat instead. And this is the other function where all of this gets registered. And as I said, this is the implementation. So I'll walk you through the implementation here. We are called with this object called args, and it contains all these arguments packed in, like path and the options object and then the callback. So as you saw already, the place where the assertion error happened, we check whether the args count is greater than or equal to 2. That is at least path and the callback. And then we read in all the arguments that were passed, like the path. And then the options object contains whether we want big int numbers in the whole statistics object. And we read that from args again. And then we finally construct this request wrap. So this is a Node.js internal class. So this is where we call libuv to do the operating system stuff. So it's a file operation related to the operating system, so libuv does it. And this is the function. So you're seeing two calls to uvfs_stat over here. So uvfs_stat is a function pointer. So why are we seeing two things over here? Well, when you do fs.stat, this is the function that gets called. And when you're doing fs.stat_sync, this is again the same function that gets called. So we have encoded the information for whether this is a sync call or an async call. And based on that, we register an async call or a sync call. So both of these, what do you say, functions, these arguments, and we pass in the function that needs to be called in a certain way, and it would do the calling for us. And library does the rest of the stat call. And we also pass in the callback. So when the whole operation is done, we would invoke the callback with the error, if any, and the stat object. So I guess I have explained the whole C++ to JavaScript communication. So any questions till now? Okay, so I'm assuming there are no questions. So I'll move on to explaining how I do some of my pull requests. So let's look at a few issues over here. So this one. So what does it say? There is something called the abort controller class and the abort signal class. So the specs over here, it says that it's fine if we can construct the abort controller object using the new keyword. So we are, okay, I'll take you to the fork of Node.js. I have to demonstrate this to you. So when I run Node and do abort controller, when I create a new abort controller object, this works. It creates this object for us. It's experimental. That's what this warning says, but it's completely fine. So this works. And when we do new abort signal, this also creates an object for us. And this should not be legal. If you look at the specs in TC39, it forbids us from constructing a new abort signal object. So this is exactly what this issue is trying to say. And let's try to see if we can fix that over here. So let's first look at where abort signal is defined in the first place. So I'll grep for that over here. As I said, it's in the lib side of things because it's written in JavaScript. So class abort signal. So it's defined right here. So let's look at the implementation. So when you say new abort signal, this is the class that gets used. So how do we prevent the constructor from actually constructing a new abort signal object? Well, let's look at what this says. So when we try to invoke the constructor, this should give a type error, which should say that it's an illegal constructor. So let's see if we can create the error inside Node.js first. So type error. As you can see, it's a global. And what happens if I call it with, say, illegal constructor? As you can see, it creates this error for us. This is exactly what we want. So let's just make a constructor over here which just throws the type error. Yeah. What happens now? The problem here is that when we do this, there are a few other parts of Node.js which actually constructs the abort signal object internally, and this would crash for those functions, calling that, hey, that's illegal. So here is the other place where it gets involved. So in the constructor of the bot controller, we use another bot signal object we constructed over here, and this will not work if we have this over here. So a little typo. So how do we prevent this? Well, there is a different way of constructing an object in JavaScript. So let's write a function to do that. So we need a new bot signal object, and we want to construct that manually. To create a bot signal, and let's define the function right here. So this should return an abort signal object, so let's call it sig, and we'll define it over here. So as you can see over here already, the abort signal class, it extends from the event target class, which is a part of the internal. So it's inside lib internal event target, this one. So let's construct an event target over here. By the way, it's completely fine if we construct an event target object like this. It does it for us. And so let's do this. So this is currently just an event target. So now we need to say that the prototype of this should be the bot signal class. So we can do object dot set prototype of sig to abort signal. So this is where the problem lies. When we are using things like object.set prototype of, this is something that's exposed to userland. So JavaScript is a pretty funky language. You can tamper all of this any way you want. And so you basically end up messing up the whole of Node.js. So we don't want people to come and file bug reports to us because you mess up with Node.js. We want bug reports if we mess up with Node.js. So that's why we have this thing called primordials. It's this object, which again is exposed to the internals of Node.js only, and it contains these functions like object.set prototype of. It's named differently. So instead of having two words, it's just one word, object set prototype of. And that is created in the bootstrap stage of Node.js. So that is not exposed to userland, so there's no way it can be tampered. In case this gets exposed, again, please feel free to file a bug report saying that, hey, this is wrong, you shouldn't do this. And we have to get rid of this dot and call it correctly. And if I search for it, it's not defined in this file. So we have to require it from this primordials object. So we try to keep everything in alphabetical order. So object set prototype of over here. And the other one is the type error. So type error. And finally, since the abort signal is not aborted yet, we need to say that over here as well. So we use this thing for the abort symbol. It's a symbol over here. So this is defined over here. So symbol K aborted. And we assign false to that thing. So when we create an abort signal using this, it would create an abort signal that's not aborted yet. So let's give this a whirl and see if this works. Let's run make to build Node.js again. Okay, so this builds, and this is executable. So when we do new abort signal, this should throw a type error. There we have it, an uncaught type error. And what happens when we do new abort controller and assign it to say A? It creates the abort controller for us, and it has the abort signal on the inside as well. So it says that it's not aborted yet. So this works. So I have sent a pull request over here and this closed the issue. So this problem has been solved. And moving to the next issue. This again is an interesting problem. So let's see what it does. So, it seems like a nice issue. It has a reproducible code over here, a nice little code snippet which you can run. And it says that if you run this, you'll get to see an error. And this is the log. So let's try to reproduce that on our system locally. So I'll create this file called test.js and paste in this thing. The first thing I notice is that HTTPS, it doesn't get required, so we need to require this. And let's run this. It seems to work for some reason. I guess I need to create Node.js again. Let's see. Done. So let's see if this fails now. Boom, we have an error. And it's coming from the C++ side because, as you can see, it's on this v8 handle scope create handle function, which clearly looks like C++ code. And there's a fatal error that's leading to this whole Node.js process to abort. So what is happening here? So let's study this log. So this the error is coming from node:abort, and clearly this is supposed to do the abort stuff, and there's nothing wrong. So who's calling it? On fatal error. Clearly there's an error somewhere, and that's why this is calling abort. And this is getting called from v8. And because it's coming from the report API failure function from inside v8. So is this a bug in v8? I don't think so. Let's look at the way we are invoking v8. So this is where we go to the end of the Node.js layer and we enter v8. And this is where v8 does all the computation and reports this error. So this is the final function we pass through. Invoke queued inside the TLS wrap implementation. So let's look at this. What could go wrong with this? copy this and git grep inside src because it's C++. Yeah, this is the implementation because it has a return type and it has this curly bracket over here. So let's look at this code. Invoke. So this function takes in a status integer and a char pointer, which is a string. And let's look at how this works. So this is C++ stuff going on, and then there's reset, which is not something that could go wrong. What looks suspicious over here is this call, the end of this function, arrow done. So what's the done function up here? To see that, we need to look at what W here is. So it's a right wrap pointer. So what's right wrap? Is it defined anywhere over here? Doesn't seem like this is the only place where it's getting called. So let's search for it. Okay, it's probably a class. So okay, so it's defined inside source stream base.h. Let's look at it. So this is the forward declaration of it, and this is a pointer, and this is the definition of the class. So you're searching for the function called done. So is it over here? No, it doesn't seem like. The whole implementation ends here. So where could it be? So it extends from the stream rec class. So let's search for this. Is it in this file? Yep, it's here. So it doesn't extend from anything else. So I guess we could find done right here. There it is. So this is the function we want. So it's an inline function. So going by the convention we follow inside Node.js, we define the header stuff, all the declarations inside .h files. The C++ stuff goes into .cc files, as I mentioned already. And then there are all these inline stuff. There are templates, which you can only inline, and those go into files that are suffixed with -inl.h files. So since it's src/stream base.h, the corresponding file should be src/stream base-inline.h. There it is. So you're searching for stream rec. So yeah, this is all there is to this file. And where is the done function? So let's search for it. Here it is. So what's going on here? So it's creating this async wrap object. Rather, it's getting a reference to the pointer returned by get async wrap. And then it has this environment object. And then it calls async wrap object set. So when you see something like object and then set going on, this is basically invoking V8 code. How do I say that? Well, look at what's happening here. So it's calling this function called 1-byte string. What's 1-byte string? Let's see if it's defined in this file itself. I'll open another tab and go to the first definition. Doesn't seem like. Let's try grepping for it again. So git grep 1-byte string inside src. So as you can see how it's getting used, the result it returns, it gets assigned to a local string object. So what's a local string? You remember when I showed you the node_file.cc file, the whole FS module implementation from the C++ side, and I showed you this initialize function. It had all these variables that were having this local thing attached to it. So local is a V8 type. Specifically, it's V8 local. So if you want, you can look at the very implementation, rather the declaration of the file over here. So say I'm searching for a local. So something of this kind. So let's look at v8.h. This is the whole file that gets included when you do include v8.h. And let's look at local. This is the one. So it's a class inside v8. So what should we do over here? What's going wrong? 1 byte string returns a local. If you look at the documentation of Node.js, it's really well documented. So if you plan to work on the C++ side of Node.js, you can go into the source folder, and there is this README over here, and have opened the part that's relevant to this over here. So this is the part. So when a local handler is created, a V8 handle scope or a V8 escapable handle scope object must exist on the stack. Local is then added to the scope and deleted along with it. So as you can see, even handle scope gets prefixed with V8 colons. So even that's something we expose from inside V8. So we can even take a look at handle scope right now. So this is a function, it's a friend. So let's see where it's defined. Okay, so this is the one. It has all these macros to the left, which gets expanded so that you can export this, and when you link to V8, and you can use them as a shared library. So handle scope is what we need over here. And in fact, if you look at the error log, it says that right here. So fatal error, cannot create a handle without a handle scope. So let's try to use a handle scope over here. So we need V8 handle scope, and then handle scope, and isolate. We basically pass in the current instance of Node.js so that it can create a handle scope based on that. And let's compile Node.js again and see if we can fix the error. And it's compiled. So let's run Node.js test.js. Boom. There is no error anymore. So this solves the error for us. So that's the end of the presentation. So thank you very much. So do you have any questions? Okay, so no questions so far. So I guess I've clarified most of what Node.js does under the hood, and you guys have a basic understanding of what's really going on underneath. And probably I can expect some PRs from you Postmanauts. So let's see what happens. I guess there's some in the chat. Oh, thank you very much. Okay, so in case you have any problems with contributing to Node.js, or you're stuck with any issue, or you're having trouble finding a new issue to work on, feel free to DM me on Slack, and I would be very happy to help you out. It's my dream to have at least one more Postman out working on Node.js, because it's really something we can show the world that we are really great engineers, all of Postman. Okay, then. So I'll stop sharing the screen. Thank you very much. Bye all.